Now, throughout this course, we learned a lot about React. We learned a lot about how to build React applications and which different features you can add there. But of course, up to this point, we only built and tested our React website locally on our local machine. We spent our entire time in this course on development. We just wrote code and tested it. And of course, that is the main idea behind being a developer. But ultimately, of course, when you build a website, when you build a React app, you want to push it onto some real server to expose it to users from all over the world. And therefore, this course section is about deploying React apps. In this course section, we are going to explore how you can move from development to production and how you can publish and expose your React app to users from all over the world. So how you can move your React application from your local machine to a real server. Now for this, in this course section, we are going to explore the different steps you have to go through as part of the deployment process and which pitfalls might await you. And specifically, we're also going to have a look at server-side routing versus client-side routing. And I'll explain what's up with that and why it is important. So how do you deploy a React application? How do you push it onto a real server? There are a couple of steps involved which you can go through whenever you deploy or redeploy your application. It all starts with writing your code, of course, and then with testing your code. And this might sound obvious, but of course you want to thoroughly test your application before you deploy it. You want to play around with it, test different things, see if you handle errors correctly, things like that. You want to make sure that you're shipping an application which is ready to be used. Then, as a next step, you might want to explore optimization opportunities. There are certain things in your code which you can optimize. Most importantly, you might want to look into a concept called lazy loading. And we are going to explore this concept in this course section. So that is another important part before you actually move your code somewhere. Optimize it. Now, once you're happy with your code, it's optimized and it's working, then it's time to build your app for production. And with build, I don't mean that you need to write more code, but instead we will execute a script which was written for us already, which is part of this React project we worked with throughout this course. A script which will then output a production-ready bundle of our code, which is minified and automatically optimized to be as small as possible, so that we get an output there which we can take like that and move onto a server, and will then automatically serve our users a highly optimized code package which is as small as possible, which of course matters because we want to ship as little code as possible to our users, because they will only be able to interact with our website once it's fully loaded. So shipping less code will load the app faster and therefore is better, and will be able to automatically generate such an optimized minified code bundle with a certain script, which we are also going to see in action in this course section. Now, once we get this optimized code package, which is ready for deployment, we need to deploy that package. And therefore, the next step is that we take that code, which is produced for us, which is based on the code we wrote, of course, and upload it to a server. Now, there we'll have different choices, different hosting providers which we can use, and I'll show an example in this course section, but you can really deploy it anywhere. I'll just leave a couple of notes on what matters there and what you should keep in mind when it comes to deploying your application. You will definitely need to configure your server or your hosting provider's offering, And I'll dive into this configuration together with you in this course section to make it crystal clear what matters here, what you should pay attention to, and how you do configure and ultimately deploy your code and your server correctly. Now, for this course section, as a demo project, I picked this routing project we worked on earlier in the course. This project where we have a couple of quotes and comments for the quotes and where we use React Router. But of course, you can deploy any of the example applications in this course. I just picked this one because there is one very specific optimization step I want to show you, which is related to routing. And speaking of that, let's assume we built our application, we tested the code, and we're happy with our code. We think it works the way it should. Therefore, we can now move on to the next step in line, which is that we want to optimize our code. Now, with that, I don't mean, or at least I not only mean, that we should write our code using best practices and so on, but I'm talking about specific performance improvements which we could consider. Now, for one, that includes performance improvements, for example, with React Memo, as discussed way earlier in the course already, where I introduced React Memo to avoid unnecessary component re-render cycles. In case you're not sure what I'm talking about, I linked the respective lecture. But that's not what I want to dive in here. I did talk about this earlier, and whilst we're not using React Memo in this demo application, it's now not the kind of change I want to make here. Instead, I want to introduce another very important concept, the concept of lazy loading. Lazy loading means that we load certain chunks of our code, certain parts of our code, only when that code is needed. Because it is super important to keep in mind that with a React single page application, you in the end build one big JavaScript code bundle, and this entire bundle needs to be downloaded by every visitor of your website in order to use that site. So here, if I start my development server again for this demo application, this quotes application, it is important to understand that everything we see here and everything we're able to use, like for example, being able to switch to this add a quote page, all of that is driven by JavaScript, by our React code. And that means that when we visit this page, if I enter localhost 3000 here and I visit this page, all that React code needs to be downloaded in order for React to draw all this user interface on the screen and in order for this application to be reactive. So therefore, what we see here and what we use here only works once all our code was downloaded. And that means that a user, a visitor of our website, has to wait until all that code was downloaded, until he or she sees something on the screen, and until our web application is usable. And therefore, we want to ensure that this initial code bundle, this initial first code bundle which is downloaded, is as small as possible, and certain parts of our code, for example, the code that is related to adding a quote, is only downloaded if we actually visit this part of the page. Because if I enter localhost 3000 and I only see this starting screen, and I maybe never even add a new quote, then there is no need to download all the code that is related to this add a quote feature. It will only make that initial download bigger unnecessarily because we don't need that code. And that's therefore what lazy loading is about. We want to split our code into multiple chunks, into multiple bundles, which are then each only downloaded when they are needed. And lazy loading is easy to implement if you are using routing, because you can then split your code by route, so that the code for a specific route is only downloaded when that route is visited. And therefore, let's now implement lazy loading here. In app.js, we are defining our main routes. And at the moment, we do that by importing our different page components from the pages folder and rendering them here. Now, even though those different pages are only visited when the URL matches the paths defined here, all that code is downloaded in advance because we have all these import statements here. And they are all evaluated when our code is bundled up, which will be part of that build process, which we'll see in a couple of minutes, and which is also done behind the scenes when we run that development server. So we download all the code for all those pages and for all the components those pages then use, even though we might not visit all pages. Now we can easily add code splitting here by adding another import and by importing React from React. And then we can replace those page imports with a slightly alternative syntax. For example, let's say we only want to download the code for this new quote component when a user really visits this route. For this, we can remove this import of new quote and instead add a constant named new quote. I picked this constant name because I'm using new quote here, down here, when I render this component. Now in there, I now want to store the result of calling react.lazy. That's a built-in method that will help us with code splitting. React lazy then wants a function, and here I use an inline arrow function, which resolves to a dynamic import. And this syntax might look strange now, but that is a standard modern JavaScript syntax, which is supported by this React project setup in the end. Here, as a result of this function, this anonymous function which I define here, we call import as a function. So here we use the import statement like this. Now we call import as a function. And to this function, we pass the path of this import. So pages new quote, what we previously had up here after from. Now this function here, which we pass to React lazy, will be executed by React when this new quote component is needed. And that's the key difference. It will not be executed in advance to download the code in advance, but only when it's needed. And that will therefore create a separate code chunk, which is only downloaded when this new quote page is visited. Now I'm still using the new quote component down there, but this component is resolved and loaded dynamically thanks to React lazy with this anonymous function passed to it. Now with this alone though, it wouldn't work. With this, if we reload and click on add a quote, we fail here, and if I directly try to visit /new quote, we get an error that React component suspended while rendering, but no fallback UI was specified. Now what does this mean, and where is this error coming from? The problem we have here is that we are downloading this code only when it's needed. That's the entire idea behind lazy loading. But the problem with that, of course, is that this download can take a couple of milliseconds or even seconds maybe. Now, whilst we're downloading this code, React is of course not able to continue. We can't load this component yet until the download completed. And that's why we need to define a fallback UI, some fallback content which can be shown if this download takes a bit longer. And for this, we need to import another thing from React. We need to import the suspense component, a special component provided by the React library itself. We need to wrap this around the code where we use React lazy. So for example here, inside of the layout, we can now use this suspense component and wrap this around the switch statement. And then on this suspense component, we need to set a fallback prop. Fallback wants some JSX code as a value, which is shown as a fallback. For example, a paragraph where we say loading. or this loading spinner maybe, which we also have. I could create a div with a class name of centered. That's a globally available class. And in there, I output my loading spinner. And for this, of course, you need to import the loading spinner, which is a component that already exists in this project. With this div, with this loading spinner, would be shown as a fallback if loading the code for this new quote component takes a bit longer. And now with this, if we save this, I can visit /new quote, and we briefly sometimes see that loading spinner, but typically we don't because downloading the code is rather quick. And if I go to all quotes and I load this page, I'm also able to navigate to add a quote. Now what's interesting is that if you go to all quotes or to just localhost 3000 and you reload this page, if you open the developer tools and go to network to see all the network requests that are being made, if you now click on add a quote, you see this request to this JavaScript file. The name might differ for you, but you see a request that is being sent to another JavaScript file. And that is that JavaScript file with the code that is related to this form and to handling this form. And this code is now only downloaded on demand when we visit add a quote. And that's lazy loading in action. Now, of course, we're not restricted to using lazy loading for the new quote page. We can also use it for quote detail. Here we can define a quote detail constant and use React Lazy like we did it before, but now for /pages quote detail. And now we can and we need to get rid of this import. We can, of course, do the same for the not found page, React Lazy, and then import pages not found and get rid of this import, and so on for all the pages. We can also do this for all quotes, but of course, if we assume that most users will land on this page anyways, loading it lazily is a bit redundant because the code will be needed anyways. But still, since users could also start on the new quote page theoretically, we might want to load this page lazily as well. So also import /pages all quotes here and get rid of the import down there, up there. And now all the code is loaded lazily and our application should still work fine here. If we reload, this all still works, but now it uses lazy loading to split our code. And lazy loading can be an important building block of an application, therefore, because it makes that initial code bundle smaller. Now, for very simple applications, like this one arguably still is, it is totally optional. But especially for large applications with lots of pages, where all the pages then also have a lot of components and complex logic attached, in such applications, lazy loading can really shine and can make the initial loading of your website much faster, because not all the code is loaded at once, but only the code that's needed.